Hi, everyone. My name is Thomas Garnier. I'm the co-creator of Sysmon and a security architect for Azure. Today, I would like to talk about Sysmon, the origin of Sysmon, what it is, how you can use it, and discuss some hunting you can do with the latest events we added. Back in 2014, when an incident happened and we're trying to figure out what was going on, we were really chasing the attackers. We were trying to figure out what was their entry point, how they make it to the system, how they moved in the system, what kind of access do they have, which data they got access to. And the tools that were available on Windows at the time were pretty limited. Process creation event didn't have any command line included into it. You didn't have a lot of information about DLL being loaded, network connection, or any of the techniques attackers would use. Often, the best thing you could do was take a forensic snapshot of the machine, do offline analysis of it, and that will take hours. It will give you very limited information about what was going on, and it was just not ideal. And you were really chasing things happening, not really having a clear picture of what was going on. To provide you an example with that, was process creation event, which is the 4688 event on Windows, didn't used to have the command line. So what you would see is query, net, you would see a SVC host on the wrong path. It clearly looked like suspicious. You see ping, net, copy, but you didn't know really what happened. What you wanted to see was the full command line so that you could basically see that you had reconnaissance being done, the credentials were dumped, and there was lateral movement happening. So you could figure out exactly, okay, the attackers went on this machine, they used this malware, they used these techniques, and they moved to another machine, and you kind of define then the access the attackers had, but it was very hard to do so. So what we wanted to do was to move from chasing attackers to hunting them. And what we really needed was like Sysinternal Procmon as a service, which later became Sysmon. So we wanted to see process creation, DLL loading, and the ability to see different techniques the attackers were using. And we knew that a tool was faster to adapt than the operating system could ever adapt. We also knew that you needed a way to scale the event and do analysis effectively outside, which was pretty hard to do before. There was also a sense of like you need to improve Windows, like the baseline for process creation events, security events, system event had to be good enough so we could figure out things if the tool was not there. Also, if we were to build a tool, which we thought was the way forward, we knew that we might need to change Windows so the tool will get better. And so that was also useful for us to do that so that all the tools that people would use could benefit from improvement into the operating system. And so that's kind of why we created Sysmon. So let's go over an overview of Sysmon, what it does, and how you can use it. The Sysmon is a free tool that is available to download on Sysinternals. It's a service running in the background. It's a service and a driver. They run in the background. They collect information about the operating system, and they send it to the Windows event log so they can be forwarded off the machine. The goal is to be able to do both logging a lot of what's happening in the operating system and be able to see attacks and anomaly of what's going on. For example, we collect the hash of processes so that you can see that a certain process has been seen only a very limited set of machines, or you can see the same malware being used in different places. There's a configuration that allows you to define exactly what you want to collect or not collect. And we designed the events that are saved and can be moved across the machine. We designed them so that they are easy to analyze. A good example for that is that usually when you have events, you have a process identifier. And that process identifier is not unique. It's only true on the OS at the moment where you took that event, when you built that event. And so if you wanted to look to an event and then cross-reference it, you had to take that event, the process ID for that event, and you had to go backward in time to find which process was on that machine with that identifier at that time. So instead, for Sysmon, what we did is we create a process GUID, a unique identifier, which is unique across all the machines on your environment. And so now the search is just a key value pair. So you see a process GUID, and then you search that process GUID in the past, in the future, anywhere. It's just you only have one with that process GUID. Sysmon was created by Mark Russinovich and myself, with contribution for a whole bunch of people at Microsoft helping to improve the tool. Here's the high-level architecture of Sysmon. You have an executable, which is an installer. You launch that, it will install it on your machine. It will install a driver and a service. Both the driver and the service collect information about the operating system, and all the events are sent to the service, where there'll be a process correlation, there'll be filtering. And so once the events are filtered, they are saved into the Windows event logs for collection. The service also monitors if the configuration changed, so it can reload it and stay up to date without having to restart the service or the driver. Sysmon has a lot of different command lines that are very easy to use. You can install it with -i-accept EULA. You don't have to set the configuration. By default, it will just save the processes that are being created, but the configuration will give you way more options, and I'll go into some example and show you how you can use it. You can also update the current configuration, as I said, like you don't have to restart the service or the driver, it will pick up the new configuration automatically. You can dump the current configuration, so if you only use -c, you will see the current configuration being used. You can both dump the schema for the configuration, so if you want to learn about new events, that's a way to do it through this or the documentation we provide. You can install the manifest for the event, which is useful for you if you took events from Sysmon, from a machine, and you want to read them on another machine. You have to install the manifest to do that well. And of course, you can install it pretty easily with -u. So one of the main features of Sysmon is event filtering. That's what allows you to scale in and out how many events you can collect or you want to collect. And the way it works is that you have a configuration file with inclusion or exclusion rules. The rule system will take the exclusion rule to see if it needs to exclude an event, and it will go through any inclusion rule as needed, so that you can basically define, I want to collect this, I want to exclude this, I want to include that or not. If you have an exclude rule, then everything else will be included, but you can have both of those rules at the same time. Sysmon is clever enough to understand when it doesn't need to listen to the sources of events. So if you exclude all the events for a specific event type, then Sysmon won't listen to any of the sources, so it doesn't use any of the CPU or the memory for the operating system. We also support a long list of different filters you can apply. I put the list there, and we keep improving it, trying to make it very useful, as easy as possible to use and useful. I provide an example of a configuration here where on this configuration, we decided we're going to collect the hashes for images for SHA-1 and 256. And when driver load event happen, if that driver is signed, the signature is valid, and the signature likely contain Microsoft Windows, we're going to discard these events. Or any other events from driver load will be logged, but those ones will be discarded. That allows you basically to define, I don't care about loading of Microsoft Windows drivers, but I care about anything else. And so that allows you to define how you can scale your environment based on the noise you see in your environment. You can tweak that. The configuration also allows you to create rule groups. The rule groups are useful for two things. The first one is it allows you to change how the fields are checked for a match for exclusion and inclusion. By default, we do an AND on all the fields. So all the fields have to match for that filter to work. But you can change that to see if any of the field matches, then that will be matched for the inclusion. So example here I have is create remote thread, where I set up a rule group of group relation OR. So that means that if the source image is CSRSS, or if the source image is WinLogon, then I'm going to exclude that event. The other reason like rule groups are useful is that you can attach a name to it, and that name will be embedded within the event. So the example I have here is for credential dumping. I set a rule group for credential dumping, and if it matches, then the event that will be generated, the process access event, will have a rule name field with credential dumping. When you collect that event, you can basically know that that's linked to that specific rule that was matched. That's very useful when you're doing hunting and you're trying to pinpoint very specific techniques, so you don't have to remember why you set up that event in the first place. The rule name helps you for that. You can also add that name to any field that matched that can be a source of help. And we have some configuration in the community that doing that instead. Here's the list of all the events we support right now, 26 of them. We keep growing that list. Every time we find there's something useful that we can collect and filter. I think last time we made a presentation about Sysmon, we had about 18. Now we added WMI support, we added DNS query, we added file delete, archive or logs, clipboard monitoring, and process tampering, which is detecting things like process overloading. And later in the presentation, I'm going to show you some example of how you can use some of those events for hunting, what kind of things you should look for. Now I would like to talk about some of the amazing community contributions that we have that could be useful for you. I want to go over 2 examples, and then I will give you a list of others that are very useful and helpful. So the first one I want to go through is the Sysmon config by Swift. That's a good starting point if you want to learn about Sysmon and if you want to build your own configuration, reducing noise of things that are not really interesting to collect. I'll put the link there if you take a closer look. I also put an example that shows you how the configuration is structured. So usually there's always like a large comment that explains what is the event, what you can learn about the techniques that are related to that event. And often what I like is that there are a lot of comments about why something was included or excluded, so you really understand how the configuration was built and why. I think it's one of the great configuration you can use to getting started if you don't know how your environment behave. And you can tweak it based on what you need. Another amazing configuration is the Sysmon modular by Olaf. It takes a kind of different approach to how you build a configuration. It has default and a verbose configuration if you care about that, but it does 2 things really well. It's a very modular, so you can build your own configuration based on your need, and it ties every configuration choices to the Meyer attack framework. So depending on your environment, depending on your risk, you can choose to include something or not. And that's a good way to see as well the coverage you'll have with that configuration. And if you look at the GitHub repo for that configuration, you can see all the files, and each one basically has a special include, exclude for different reasons. So if you look at the CDN network for DNS query, it has a list of all the CDN query names that you want to exclude and the reasons why you would like to exclude them, which is very useful in an environment where you're going to see a lot of DNS queries and there's a lot you might not care about. So here I put a list of guides, configuration, and signatures available for Sysmon. And we're very grateful for all the people that helped understand the different events, how you can deploy Sysmon, how you can analyze the events across Sysmon and other themes. So it's something that documentation can never really fully cover, and we're very grateful that everybody is helping Sysmon to be used better. So thank you, everybody. So now that you have installed Sysmon, you set up the configuration, you maybe use some of the community configuration or guides, you need to collect those events. I'm going to go through 2 examples of that. One of them is Splunk. So for Splunk, you can use the universal forwarder. I put 2 links to it, the official link for Splunk that links to the universal forwarder for downloading, and also a link to Olaf's GitHub repo who forked some of the previous scripts that were available that can be useful as a starting point. You can set that up and to basically gather all the Sysmon events to your Splunk instance. And on your Splunk instance, you can install this Sysmon add-on that is not supported by Splunk so that it will correctly parse the events and allow you to query them faster. We also advise you that you exclude the Splunk binaries from being analyzed. And I added some of the rules you could use for that so that those events are not forwarded to Splunk and you don't get additional noise. Another way you can collect as well the events for analysis is Sentinel. So Sentinel support the analytics and the parsing for query of Sysmon events. The way you would do that is you install the Azure monitoring agent. You configure that agent to take the Sysmon event out. And then on your Sentinel instance, you install the Azure Sentinel Information Model, or ASIM, that will allow you to automatically parse those events so it can be queried like any process creation event on Sentinel through the different views. And I put 2 different approaches you can do that for the views. You can use the Sysmon view that shows you the process, or you can use the generic process information source to see that as well. Now I would like to make an announcement about a partnership that we're doing with VirusTotal. So VirusTotal is this online portal where the community shares malware samples and IOCs in general about threats. And it's a very useful tool if you want to learn more about a family of malware, variants, and how detection is doing in that space. For example, you can see all the AAV results and some of the behavior in general from that malware. The partnership is that we are working with VirusTotal so that the SysInternal's metadata are included within the behavior analysis of VirusTotal. And the Sysmon metadata will be available soon. What it means is that when Windows malware is uploaded to VirusTotal, we'll launch in Azure a near real-time analysis of that sample. And all the metadata will be summarized and sent back for everybody to use. We think it will be very valuable for the community to be able to have access to that information. And we think it will drastically improve the response time from any of the security product. They can very quickly see the similarities of behavior and allow them to tweak their detection much faster. So we're very happy with that partnership. Let me give you an example of how it will look like. So that's still work in progress, but those are basically screenshots of how it will look like. In the behavior tab, you'll have the Microsoft SysInternal, the Sysmon information, and that will include things like network communication and different file systems, like which file were deleted, which file were dropped on the machine, which registry keys were set for persistence. And you have a lot of information about process created, terminated, and the process tree. So you can basically see how the malware is trying to stay on the machine, what kind of traces they will leave, which is very useful. We're very happy with this partnership. Now let's go over a couple of events and some of the latest Sysmon events and see how they can be used for hunting. And let's start with the DNS query event. So the DNS query event allows you to see which process doing which DNS query. Sometimes you can see that on the environment, depending of the log access you have, you see this machine or this part of the network is doing this kind of DNS query. It's very useful to see on the machine which process is doing it. And you want to see those DNS query because it allows you to identify different malware behavior. You can identify miners, you can identify connection to a C2, you can see a connection as a Tor client to the Tor network. And a machine does a lot of DNS queries, so we advise you to look at the community configuration that I talked about before so that you can reduce the noise to start with. Sentinel also provides you on the GitHub repo a list of miners, hosts, and Tor proxies as well, which is very useful to start with. So the DNS query event looks like this. And I took an example of a miner. And so you can see that the query name is a known miner host, so you know that process is likely to do mining. The image is explorer.exe, which is strange because that's part of the Windows operating system. And if we do that correlation I talked about before, if you take the process GUID of that DNS query and you search it for the process creation event, you can see the Explorer instance that did that DNS query. And there's something strange with it because you can see that the command line doesn't look like the typical Explorer command line. He has those weird algorithm, and you can even see the miner DNS basically host name on the command line, which is very odd. So that transitions well into the other event I want to talk about, which is process tampering. Process tampering tries to detect techniques that are used to hide a process, such as process hollowing. Those techniques, they are used to make a process look legitimate, but swap the code underneath it so that it will do something else. They were built to evade things like EDR or existing tools on the system so that the event and the signal you get is incorrect. Olaf had a very good blog post about this that shows basically the Sysmon process tampering events and how they can be useful and can be configured. So we had in the previous with the miner, previous slide with the miner, we had the process creation event with that strange command line. And if you were to look at Process Explorer, you could see that this process looks legitimate. The command line is strange, but the image loaded in it are all Microsoft sign. The process looks normal. And that's where the process tampering event can be useful. So if you take the process GUID again and you correlate with the process tampering event, you can see that we created an event that said that the image was replaced. That allows you to see that something strange is going on in the system. That can be very useful when you're hunting attackers. The last event I would like to talk about is about WMI and how it can be used for persistence. So if you're not familiar with WMI, WMI is a database on Windows that allows you to learn more about the operating system and have events that happen for when different things happen in general. WMI can also be useful persistence for an attacker, persistence on a file or persistence as we call fileless, where the script will be embedded within WMI. The way it works is that you can set up the WMIs that when an event happens, being a logon or a timer or something else, then a script will be executed, and that script being on the disk or in WMI. A few years ago, we changed autorun so that it will show that entry, and I have an example here. When you have a WMI database entry, they link to an event, and we show it as a way to basically keep persistence on the system. More recently, we changed Sysmon as well to see the same things. So we have 3 kind of events that show the different things that are happening on WMI leading to persistence. The glue between those events is the event 21, which is the binding event. It basically links the 2 other events. You have a consumer field that shows basically the action. What is the things that's going to be done when the event triggers? And it shows you the script that will be executed when that event happened. And then the filter is the event. It's basically a query that tells you that when a logon happened, then you need to do the consumer or the action. So if you set up the Sysmon WMI event, you can see those things happening and you figure out that persistence was set up on that system. Finally, I want to leave you with best practices and tips that are useful for you. Install Sysmon on all your systems, been proven to work at scale. And when you have a problem, you always have the data on the system available. You should configure the events based on your environment, leverage the amazing community that we have, all the guides and all the discussions online so that you can know what's the good baseline, learn about new detection techniques, and then tweak that configuration for your environment so you can scale depending on what you need. And then once you set that up, you should forward the events to offline using Splunk, Sentinel, or something else so that you can do hunting and then you can search those events if something happens. So if an intrusion happened, you can come back in time and see what happened, and you can really understand how the attackers went on the network and moved and trying to get a clear picture of what happened there to remediate better. You can use as well for hunting as saying like you can use things like anomaly detection. If you see a binary that's used only on certain machines, you can track down and figure out what it is. That's something that was very important to us when we started Sysmon, to move from chasing attackers to more of a hunting. You should really take benefit of that. So thank you everybody for watching. I hope that was useful, that you learn more about how Sysmon was created, how you can use it, and learn about the community and everybody's work to try to improve it. So thank you very much.
When Mark and I were speaking at Microsoft conferences, TechEd in particular, the TechEd speaker room used to have a whiteboard, and they would show the highest rated speakers, the average rating, updated regularly throughout the day. So Mark and I had a fierce competition as to who was the higher rated speaker, and often it was neck and neck. Mark, I would say, more than I, beat me out, but that was a source of a lot of cajoling and fun competition.